want to welcome you to the Harris family first gathering for UCI Mind and the creating of a fellowship for them. I personally want to thank Keith Swain for introducing me to UCI Mind. I want to thank all of you for coming, and I would like to thank my family, including my husband, for supporting us today, and the Brethren Community Foundation. And I would just, so that you know how many wonderful people are here, I would like the Brethren Community Foundation and my family and the UCI Mind people and Alzheimer's Association to all stand, and you see what good company you're with. There is a crisis facing all of us. More than 5.5 million people are living with Alzheimer's today in the United States. And someone is diagnosed with that disease every 65 seconds. If you look around in this room, you know, our odds are not that good. The number is expected to double in the next every 20 years. So by 2050, we'll have 130 million people with Alzheimer's. Dr. Gill told me that's a tsunami in numbers, and we can't handle it. We've got to find a cure. It's just not manageable without. Many articles are being written. I've asked Dr. Gill to try to answer some of them. People are saying you need a diet, you need to take this oil, you need to take curcumin, it's this machine that you breathe up your nose, you need to have infusions, on and on. None of that is really a cure, and we don't even know if any of it's working. And some of us who are working with all of those are struggling, because what is working? What should we be doing? It gives me very great pleasure to introduce somebody that's going to give us answers today, and that is Dr. Joshua Gill, the director of Mind Institute for Memory Impairments and Neurological Disorders. Dr. Joshua Gill, thank you for being here.
Good morning. Thank you, Harriet. Thank you, Brethren Community Foundation. Thank you all for being here today. My name is Josh Grill. I'm the director of UCI Mind. I am deeply honored to have the opportunity to tell you today why I agree with Harriet that we are facing an epidemic, a problem that I often refer to as the single most important medical problem we face as a society today. What I intend to do this morning is to give you a bit of background about the scope of the problem that is Alzheimer's disease and what the figures look like and what we face moving forward. And then I want to do, as Harriet indicated, I want to tell you what we're learning. We're really learning at a rapid and accelerated rate about Alzheimer's disease, and we have made tremendous strides in our understanding of who gets this disease, why they get this disease, what's happening in the brain when this disease happens, and most importantly, how are we going to tackle it as a medical community? And we are extremely proud, and I'm extremely proud to represent UCI Mind and the role that this transdisciplinary collaborative institute at your local university plays in the larger national and international Alzheimer's disease research agenda. So I will close by telling you about our organization. So the scope of the problem of Alzheimer's disease, you heard it from Harriet. There are more than 5.7 million Americans who suffer from Alzheimer's disease today. As importantly, this is a disease that never affects just one person. Just adjust. The disease always affects families. There are at least 15 million Americans who are providing care to people with Alzheimer's disease today. The diagnosis is made extremely frequently, but it's probably not made enough. Many patients go undiagnosed. Many patients who are diagnosed are not, in fact, told that they suffer from this disease. So there is still great work to be done in the diagnosis and the delivery of diagnosis of Alzheimer's disease. This problem hits close to home. California is affected by Alzheimer's disease more than any other state. We are home to more Alzheimer's patients than any other state, but we are also a place where people come to enjoy their retirement, enjoy their final years. And I'll tell you in a few moments, the single greatest risk factor for Alzheimer's disease is age. So we are, in fact, disproportionately affected relative to our populace. And here in Orange County, Alzheimer's disease is actually the third leading cause of death. Nationally, Alzheimer's disease is the sixth leading cause of death, again, because we are home to more people at the years of life when risk for Alzheimer's disease is greatest. People ask me all the time, it seems like more people have Alzheimer's disease today than 5 or 10 years ago. This is truth. More people have Alzheimer's disease today than ever before. In part, this results from the good work of the scientific and medical communities to extend the life. Longevity continues to increase. In fact, for the first time in human history, there are more old people on the planet than young. The number of people age 65 and older outnumbers the number of people 14 and younger. But this brings new challenges, and none greater than that of age-related neurodegenerative diseases. The trends by which Alzheimer's disease has become an epidemic are forecasted to continue. In this country, it's expected that 10 million baby boomers will develop Alzheimer's disease. The first wave of baby boomers are just reaching the age of 70, and so the 5 million people with Alzheimer's disease could triple by the year 2050. This is an expensive disease. Anyone who's known this disease in their family understands that. The cost of Alzheimer's disease today exceeds $250 billion in the US alone. If the tripling in prevalence occurs, the cost of Alzheimer's disease to our national healthcare system could exceed $1 trillion. Alzheimer's disease on its own could bankrupt our healthcare system. What have we learned about the risk factors for Alzheimer's disease? Who gets this disease? I've already told you that the single greatest risk factor for the disease is age. For every 5 years we live after the age of 65, our risk of developing Alzheimer's disease doubles. But not every person who lives into their 80s and 90s gets Alzheimer's disease. Clearly, there's more to it than that. We've now identified more than 20 genes that are associated with Alzheimer's disease. Some are extremely rare and can actually cause the disease. This makes up less than 1% of all people who suffer from Alzheimer's disease. Some genes are more common and associated with increased risk, yet they are not determinant. Even taking the 20+ genes that have been identified, we cannot simply put them into an equation and calculate whether someone will or will not develop Alzheimer's disease later in life. In fact, geneticists estimate that the total proportion of risk for getting Alzheimer's disease is approximately 50% genetic, leaving 50% to be environmental. By environment, I don't necessarily mean our climate or exposure to toxins, although there are some areas of research that investigate those potential relationships. What seems to be the stronger predictor of who will get Alzheimer's disease is our lifestyle choices. Numerous things can decrease our risk. Numerous things can increase our risk. Even in midlife, cardiovascular risk factors seem to be strongly associated with late life risk for Alzheimer's disease. Hypertension, high cholesterol, cardiovascular disease all increase our risk for developing Alzheimer's disease. Alternatively, leading a healthy lifestyle, a healthy diet, regular consumption of fish, sources of healthy fats from nuts and olive oil, what some refer to as the Mediterranean diet, regular exercise. These things are associated with decreased risk. I had meant to time that up so that it would have... Okay. So can adjusting risk factors actually matter? I argue it can and it does. In the United States, in the United Kingdom, and in some Scandinavian countries, it's actually been observed over the last decade or two that there have been small but significant decreases in the prevalence of Alzheimer's disease, on the order of 1 to 2% reductions. This is largely attributed to changes in some of those risk factors, the advent of anti-hypertensive drugs and cholesterol-lowering drugs. In fact, just last week, a paper was published looking at an interventional study to see whether adjusting blood pressure in hypertensive at older age could actually reduce risk for developing cognitive problems. And indeed, that study was positive. A more aggressive lowering of blood pressure appeared to slightly reduce the risk of developing cognitive impairment and dementia in older populations. Some people still got this disease, but perhaps we can delay things by implementing larger, more robust health lifestyle strategies. In our clinics, however, we see numerous patients who did everything right, ate a healthy diet, exercised, maintained an active brain. As yet, there is still no way to certainly prevent this disease. Some people will develop this disease, and our research has also tried to improve the manner in which we can make the diagnosis. Another question I get quite frequently when I give talks like this is it true that you can only diagnose Alzheimer's disease after someone passes away? The diagnosis of Alzheimer's disease has improved immensely over the last few decades. There have been iterative improvements in the criteria that are used to assign this diagnosis, and the tools that are available to add confidence to the diagnosis have increased as well. The diagnosis is based on the clinical presentation, the presentation of cognitive problems, most notably memory problems, often accompanied by language impairment, problems in decision-making, etc. We now believe that we are on the cusp of being able to make this diagnosis before someone is impaired in their ability to live life by these cognitive problems. This is a construct called mild cognitive impairment. Someone has memory problems or other cognitive problems, but they can still live life the way that they once did. This population is at substantially increased risk to suffer progression in their cognitive problems and meet criteria for Alzheimer's disease. These clinical presentations, however, are not definitive. And it is in fact true, the definitive diagnosis of Alzheimer's disease is made only when confirming the biology of this disease in the brain. But our tools to support this diagnosis have increased substantially. I list some of them here. And I show you an image of a typical MRI scan of someone older with normal memory versus someone older with Alzheimer's disease. And you can see the characteristic patterns of change that we envision in many people with Alzheimer's disease, a loss of tissue, specifically in the sides of the brain that are most critical to the process of forming new memories. This part of the brain is called the hippocampus, and what you're seeing here is a prototypical atrophy of this brain structure, hippocampal atrophy. A person with memory problems, language problems, and an accompanying scan that looks like this compared to this is more likely to have Alzheimer's disease than someone without a scan like that. Still, this scan is not 100% sensitive or specific, And the gold standard diagnosis comes when we can actually visualize the presence of the hallmark pathologies in the brain associated with this disease. Every person who dies from Alzheimer's disease will have the presence of what are known as amyloid plaques or neuritic plaques and neurofibrillary tangles. When Alois Alzheimer first characterized this disease more than 100 years ago, he followed a patient who presented with memory and other cognitive changes. He examined her brain when she passed away, and he recognized that there were two abnormalities that did not belong in her brain tissue. These two things, plaques and tangles. And today, they still make up the crux of what is Alzheimer's disease. And until recently, the only way to visualize the presence of plaques and tangles was through histopathological examination after the person had passed away, that is, at autopsy. However, we now have tools that let us visualize the presence of both plaques and tangles while a person is still alive. 3 brain scans have been FDA approved to visualize the plaques in the brain. This scan is available. It adds great confidence to the diagnosis of Alzheimer's disease, and as importantly, we are using it in numerous ways to rapidly accelerate our development of treatments in clinical trials. The first scans to visualize the tangles have recently entered the research space. They are not, as yet, FDA approved. Once they become FDA approved, which many of us foresee to happen in the next 5 years, I believe we will be able to make the definitive diagnosis of Alzheimer's disease when a person is still alive. The availability of these tools has shown us a great deal about what is happening in the brain of a person with Alzheimer's disease. And perhaps no finding has greater significance than the clear demonstration that these plaques and tangles accumulate in the brain before symptoms begin. I mentioned mild cognitive impairment. By the time a person with Alzheimer's disease has mild cognitive impairment, plaques may actually have achieved their peak, a plateau. Tangles are accumulating rapidly and parallel the development and the worsening of symptoms. However, our studies show us that even before the onset of the first memory problems, the plaques may be present for a decade or longer. This is data published last year looking at people who enrolled in a longitudinal study where they had these brain scans and showing that older people with normal memory who had the plaques developed an onset of symptoms over time compared to people of the same age who did not have the plaques. And the accompanying editorial by an expert in our field summarized these results quite simply. If plaques are present in the brain, it is no longer a question of if, but when symptoms develop. I must share, however, that there's competition for developing Alzheimer's disease in people who have plaques present. And much of our research now aims to understand what proportion of these people will live to develop symptoms. And I apologize for this busy slide from my colleague at UCLA, Ron Brookmeyer. But the take-home message here is that only about half of people with plaques present will live long enough to develop symptoms. And these findings will be critical as we develop public health campaigns to try to prevent Alzheimer's disease. Anybody recognize either of these two individuals? Don't feel bad, even in our graduate programs, I am lucky to get 1 out of 2. This is Jim Watson. He's one of the co-discoverers of the double helix for DNA. This is Craig Venter. You may remember the race to sequence the human genome. He won that race. He led the for-profit arm of the race to sequence the human genome. It's hard to imagine any two individuals knowing more about genetics than these two. When Venter's team won the race to sequence the human genome, he chose his own genome to sequence. When the nonprofit or academic side of that race shortly thereafter caught up, they chose Jim Watson's genome to sequence. So these are also the first two human beings to have their entire genome sequenced. Venter chose to learn every single gene. And he learned that he was a carrier of the ApoE4 allele that puts a person at increased risk to develop Alzheimer's disease. Watson had an aunt who had Alzheimer's disease and said he had no desire to know if he was at increased risk for that disease, and so he tested every gene save one, ApoE. The psychologist, Steven Pinker, has been quoted as saying, I have no desire to undergo ApoE4 testing. I have enough existential dread in my life as it is. Two very different decisions from two very knowledgeable people. Someday we may be able to tell someone whether they are going to develop Alzheimer's disease. And indeed, much of our research focuses on how people will make that decision and how we should approach them with it and what we should tell them. And this will be critical, I believe, to improving our opportunities to treat this disease. Now, Harriet mentioned it. A quick Google search will yield numerous things about miracles, cures, preventions, opportunities to reverse disease. Even in our local media, we can find reports about incredible things never before thought possible when it comes to the treatment of Alzheimer's disease. My colleagues at the University of California at San Francisco on Friday authored an outstanding article in which they described what is termed pseudo-medicine for dementia, and the unfortunate scenario by which some people who stand to gain financially are taking advantage of this crisis and offering unproven, in many cases untested, therapies with audacious claims. Unfortunately, today, as I stand here before you, we cannot slow Alzheimer's disease. We cannot stop its progression. We are unable to reverse the cognitive problems that are associated with this disease. And as yet, we can't prevent this disease. I cannot give you a recipe that you can follow and with certainty know that you will never develop this disease. Not yet. But we are hard at work to be able to do these things. Our goal is to be able to do these things. Rigorous science will be essential to be able to do these things. There are FDA-approved treatments for Alzheimer's disease. The FDA has approved 5 different drugs, depending on how you categorize them. One combination of 2 FDA-approved drugs has been approved as a separate indication. They exist largely in 2 classes of medications, what I call cholinesterase inhibitors or acetylcholinesterase inhibitors, and a drug in a class of its own called memantine or Namenda. These drugs were approved because they help patients. When a person is taking this drug, their symptoms are a little better than compared to if they weren't taking this drug. This is illustrated in this figure, which I apologize if it's a bit difficult to see. These 2 red and pink lines up here represent someone taking a cholinesterase inhibitor like donepezil or Aricept, compared to a person who gets placebo. You can see that both groups actually do a little better at the beginning of the trial. That's what we call a placebo bump. Over time, we see a clear separation between the group getting the drug and the group getting a placebo. It's data like these that resulted in the approval of Aricept, Exelon, and Razodine, as well as memantine. Unfortunately, what happens if you take the drug away and continue to follow the people in the trial is that you can no longer tell who got the drug and who did not. Having taken these medications, the natural history of the disease is unaltered. These are what we call symptomatic therapies. When taking the drug, the person performs a little better on cognitive and functional tests. But the rate of progression, the risk of developing severe dementia is unchanged. And none of these drugs are approved in mild cognitive impairment, and none of these drugs are approved to prevent the onset of cognitive problems in people at risk for Alzheimer's disease. Thankfully, there are numerous candidate therapies that are in development and in clinical trials today as we speak. Many of these drugs, and I don't have time to talk about all of them, many of these drugs are what we term candidate disease-modifying therapies. They are drugs that are in development because we hope that they will be able to slow or stop the progression of Alzheimer's disease. And mechanistically, they target the underlying biology of this disease that we now understand to be occurring. Many of them directly target the plaques and tangles that Alzheimer saw himself in the first patient with this disease and that I showed you pictures of just a few moments ago. Here is just one example of a candidate disease-modifying therapy, a drug called aducanumab. Say it with me. Very good. A monoclonal antibody against the beta amyloid protein. This drug is infused into the bloodstream on a monthly basis to people with Alzheimer's disease. And in the preliminary results from a phase 1b study, a study I was a part of, it was clear that aducanumab can take a person's amyloid level in the brain and substantially reduce it. In fact, it is now understood that if a person with Alzheimer's disease takes aducanumab at high enough a dose for long enough a time, we can clear amyloid from the brain. A person who has an adequate amount of amyloid to qualify as supportive of a diagnosis of Alzheimer's disease can have their amyloid reduced to a level where that is no longer the case. There are at least 2 other therapies that have now been shown that if taken at high enough a dose for long enough a time can make an amyloid positive brain into an amyloid negative brain. It is not yet known if that is enough to slow the course of Alzheimer's disease or to prevent the onset of symptoms if these treatments are begun in a preclinical phase of this disease. The early results are quite promising, but they remain early. In this study, the higher the dose of aducanumab a patient got, the slower the disease progressed. Over 12 months, the people who got the highest dose progressed the least, compared to people who got placebo especially. These data, when first announced, were unprecedented. Though we had had drugs that could change the biology of the disease, none could do so at such a profound level. And the relationship between changing the biology and changing the clinical symptomatology of this disease had never before been seen. We're not there yet. The phase 3 studies of aducanumab are ongoing. We are following patients at UCI Mind who are participating in that study as we speak. And as I mentioned, there are at least 2 other drugs that we are not currently studying at UCI Mind that have been shown to be able to clear the plaques of the brain. Will it be enough? Remains an open question. One question is, how early must these treatments be started for them to be effective? If the disease builds up over the course of a decade or two, when must a treatment be begun in order to be effective? We are following about 30 people, like my good friend Paula Hunter, seen here, who was on the cover of the Orange County Register a few years ago. Paula enrolled in a clinical trial that was looking for cognitively normal people, no memory problems whatsoever, who are willing to have a brain scan and learn if they were at increased risk because amyloid plaques were already present in their brain. More than 1,300 people, continent-wide, are now enrolled in this study, which is called the Anti-Amyloid and Asymptomatic Alzheimer's Disease Study, or A4 trial, where we're testing a different anti-amyloid therapy to see if we can stave off the onset of memory problems in people at greatest risk to develop them. Before I leave treatment, another analogy I like to make is not only how early must we intervene, but how much must we intervene? And I've made clear that we have to determine how high a dose of these drugs will be necessary, how long someone must take them. But what if one drug is not enough? In HIV, we didn't turn a deadly disease into a chronic condition until we had 3 drugs that could be combined in a cocktail. Perhaps we will need not only anti-amyloid therapies, but anti-amyloid, anti-tangle, and anti-inflammatory changes because the brain experiences a robust inflammatory response to Alzheimer's disease as well. And combination trials to this point have largely eluded us, but they are coming soon. So where does UCI Mind fit in this large agenda? I've made clear that we're participating in a number of these studies. We work closely with drug companies. But this institute, which I joined in 2015, has a remarkable history. We were one of the first ever Alzheimer's disease research centers. The initial funding of these congressionally mandated centers came in 1985, funding only 5 centers in the nation, and UCI was one of them, in partnership with USC. It was a joint center that was split at the recommendation of NIA in 2000, and so USC and UCI are now independent centers, but we partner on a number of things. In fact, to be a member in this center means to be a member of a national network that works closely together, in fact, contributing data to a single data clearinghouse so that we can answer questions more rapidly about figuring out how to defeat Alzheimer's disease. UCI Mind is a transdisciplinary institute. We have more than 50 faculty from more than 10 different schools and departments. At most Alzheimer's centers around the country, they're really in the Department of Neurology, perhaps in geriatrics or psychiatry, and most of the members of the ADRC come from that department. Nothing could be further from the case at UCI. We have faculty from the School of Medicine, the School of Biological Sciences. I happen to be a faculty member in both. We have faculty in the School of Education, Information and Computer Science, even one faculty member from the School of the Arts who studies the neuroscience of dance. The point of this organizational structure is to bring not only numerous types of expertise, but numerous approaches, people who will challenge each other, people who enable each other to ask novel questions they couldn't ask on their own to accelerate the knowledge gained, the research progress to do something about Alzheimer's disease and other age-related conditions. We're a handsome group. No, I'm kidding. We've been home to numerous scientific discoveries. Carl Kottman, who just got a new NIH grant this year, but was the founding director 30 years ago. Still very active, has made numerous discoveries on his own, discovering the role of exercise in production of a protein in the brain that's good for brain cells called brain-derived neurotrophic factor. He's now co-leading a clinical trial of exercise as an intervention for people with mild cognitive impairment, hoping that it might be able to slow the course of the disease. Frank LaFerla, who was pictured on an earlier slide, is now Dean of the School of Biological Sciences at UCI, still the director of the Alzheimer's Center, discovered the triple transgenic mouse, the first ever animal model to get plaques and tangles. Many people credit him with rapidly accelerating the field himself with this discovery, happened at UCI. You may have heard of Claudia Kawas and her world-famous 90+ study, featured on 60 Minutes, among other media outlets. They have really led the world in understanding what happens to the brain in the 9th and 10th decade of life in people lucky enough to reach those ages. Ira Lott is one of the world's leaders in the link between Down syndrome and Alzheimer's disease. He now has a $14 million grant to understand what happens in the brain of older people with Down syndrome as it relates to Alzheimer's disease. We have numerous faculty who are among the world's leaders in understanding the inflammatory response to this disease, although some of them would lambast me for characterizing it that way because they believe inflammation comes first in this disease. They have ideas that will lead to new candidate therapies. And I hope novel clinical trials, perhaps in combination with anti-amyloid therapies, that will be unique to UCI. UCI is home to a world-renowned stem cell center. We've done incredible work on stem cells as possible treatments for Alzheimer's disease, but more importantly, I'll tell you about how we use stem cells as a novel tool in our research. Some of our investigators have developed antibodies against amyloid plaques in particular that are used as research tools worldwide. And one of our investigators has really made a name for a role of a less studied cell in the brain called microglia that I won't belabor today. This is a picture of the network of the Alzheimer's disease research centers. Again, you can see California, which has been disproportionately affected by Alzheimer's disease, is also home to more Alzheimer's centers than any other state. But UCI Mind is the only such center here in Orange County. We collect data as a part of this study on roughly 350 people annually. We send it up to Seattle to be combined with the data from all other centers around the country. So we have more than 14,000 people whose data go into this clearinghouse that we can use to answer research questions. The center is composed of cores. Again, the cores in part represent the unique forms of expertise. Dr. LaFerla, who's a neuroscientist, Dr. Kawas, who's a neurologist, Dr. Dan Gillen, who's chair of statistics at UCI, who's obviously a statistician, Dr. Ed Minucci, who's a neuropathologist, myself, and Dr. Matthew Blurton-Jones, who's a neuroscientist. I mentioned that we study 330 people who are at risk for developing Alzheimer's disease, as well as people who have experienced these symptoms, the 90+ study, and the Down syndrome program, all of which on their own are making tremendous strides and widely known nationally. Dr. Blurton-Jones leads what's called our Induced Pluripotent Stem Cell Core. This core was the first of its kind in the nation. It takes skin cells from people participating in our research, including from each of those 3 cohorts that I described on the previous slide, and reverse engineers them in the laboratory to become pluripotent stem cells, cells that can become any cell in the body, including all of the cell types in the brain. Doing so, however, those cells maintain the genetic background of the person who donated them. So in this core, we can make stem cells from people who have Alzheimer's disease and people who don't. And we can study the genetics of this disease in the dish in a way we never could before. And in fact, this core, which was highly innovative, the first of its kind, was made possible by a philanthropic gift by Mr. Keith Swain, who Harriet acknowledged at the beginning of today, and now has produced something like $20 million in NIH grants from the cells that are generated and shared broadly through the research community. Dr. LaFurla and an outstanding team of investigators were funded last year to create the next generation of animal models for Alzheimer's disease. Though his first model to develop plaques and tangles transformed the field, it's time to transform it again, because the genes that were involved in that animal model were exceedingly rare. They are now planning to use the more common genes that have been identified to develop animal models that will hopefully be better predictors of human outcomes, especially for testing new treatments. And I've made mention throughout this presentation that we are very focused on testing and doing so in a rigorous, gold standard way, candidate treatments that we hope will be improvements to our armamentarium of therapies for people with Alzheimer's disease. So we are testing the aducanumab drug. We have funding from the University of California to do a very cutting-edge biomarker clinical trial of nicotinamide, which is a component of vitamin B3 to see if it actually can counteract the tangles in the brain of people with Alzheimer's disease. And I pointed out the first ever study in people who have amyloid in the brain but normal memory, what we call preclinical Alzheimer's disease. So I end every one of my community lectures by telling people what they can do to help us in this cause, and I refer to it as my 3 8s, because everyone can advocate, donate, or participate, and each of them will be essential to making an impact on the public health of Alzheimer's disease. So you can advocate. We've worked really hard to no longer be known as Orange County's best kept secret. We've tried to get the word out that UCI Mind is here and has been here for a long time and needs your help. And so you can advocate for us. You can advocate for families with this disease. There aren't enough resources in place for families dealing with Alzheimer's disease. I'm especially grateful that the Alzheimer's Association is here today, and we rely on our community partners. One thing UCI Mind does not do is provide family support, and we're grateful that there are organizations here in Orange County that do that so that we can focus on what we're best at, which is doing cutting-edge research. You can donate. Keith Swain made a gift that made that induced pluripotent stem cell core possible. It transformed research not only at UCI, it made research nationwide, and now cells have actually been shared internationally possible that wasn't possible before. NIH is very good at funding research. The Alzheimer's Association is very good at funding research. But what we do with philanthropy is we fund risky research. Research that may not work, but that if it does, it's going to move us forward by leaps and bounds rather than the incremental advances that traditional research funding does. And you can participate. This extremely good-looking, suave, debonair individual pictured in this slide was among our first enrollees into something called the Consent to Contact Registry, or C2C. This is an online registry where people can enroll with no risk. It's confidential, voluntary, free, and it lets us match you to a study if a study is right for you. You tell us about yourself, as well as what you might be willing to do in a research study so that we don't contact you about something that you wouldn't be interested in doing. We think of it as a dating service, matching investigators to people who want to help. It is actually already accelerated research at UCI. We are able to do studies more quickly. The single greatest barrier to testing new therapies is actually slow enrollment in our clinical trials. And this is a direct response on our part to try to accelerate that aspect of what we do. It now takes longer to test a drug in human patients than it does to develop it in the laboratory to get it to the point of human testing. So I end every lecture by talking about the 3 8s, and I hope you might consider how you can help us with one of those 8s. I want to again thank Harriet for making today possible. I met Harriet at the end of last year, introduced by Keith Swain. And it's incredible for me to think about how she has made a transformative difference in our organization in a very short amount of time. Our institute is indebted to her already. She is a wonder. She is a wonderful partner. We are extremely grateful to her for having the opportunity today. We are grateful to you for braving this inclement weather to be here as well. And I am extremely grateful to have had the opportunity to tell you about the work of more than 100 different people who have committed their lives to doing something about Alzheimer's disease through research. Thank you for your attention. So I'm more than happy to take questions.
Are there any pharmaceutical companies participating in these studies?
Yeah, so the question is, are there any pharmaceutical companies participating in our studies? And the answer is an emphatic yes. We are partnering with Biogen IDEC to test aducanumab now. We are partnering with other pharmaceutical companies, Eli Lilly, Genentech, there are a number. It's important to be clear that UCI Mind's not going to beat Alzheimer's disease by ourselves. No all academic research centers together, we're not going to be able to do it. It's going to take a partnership with other nonprofit organizations like the Alzheimer's Association, the community at large, and most certainly industry. We are heartened by investments by some pharmaceutical companies, doubling down, if you will, on Alzheimer's disease as a therapeutic area. There are a number of really promising candidate drugs that continue to be developed. Although, yesterday we had an unfortunate announcement from Genentech that another set of trials was stopped in phase 3 of a seemingly promising candidate. I spoke to someone from Genentech yesterday about that. We stay in close touch. I like to help them design clinical trials. Much of my work is about how to design trials that will be likely to succeed. We're heartened when they want to take our advice. And again, we're not going to be able to do this on our own.
In an attempt to control high cholesterol, in your studies, have you found any direct correlation with taking statin drugs?
Yeah. Yeah, so the question is about the relationship between high cholesterol and Alzheimer's disease and whether statins are directly associated with that. Statins have actually been tested as potential treatments for Alzheimer's disease, and they did not show a benefit on their own. Nevertheless, midlife high cholesterol most certainly does increase one's risk for developing Alzheimer's disease later in life, and taking a statin to reduce that cholesterol may in fact lower one's risk. Or, the other way to think about this is if it buys you some time. If someone was destined to get Alzheimer's disease, perhaps if they had had high cholesterol for longer, it would have had an earlier age of onset. By controlling their cholesterol, maybe we are delaying that onset. Worth doing, to be sure. No rigorous clinical trial of a statin has shown that a statin can delay or prevent Alzheimer's disease, but certainly anyone who has high cholesterol should partner with their doctor to think about controlling that cholesterol through diet, exercise, and if necessary, pharmacologic therapy. I like this table so far.
You mentioned briefly inflammation in the brain, and I've read that there may be a correlation between diabetes and Alzheimer's and
Yeah.
dementia.
Mm-hmm.
Can you
Sure.
comment on the latest?
Yeah. So the question is that I mentioned inflammation and that there is literature out there, including scientific literature, about a link or a potential link between diabetes and Alzheimer's disease. So science is fun because we don't always agree, and we get to argue and try to test hypotheses. And one of the debated things remains whether diabetes is a risk factor for Alzheimer's disease. Diabetes is certainly a risk factor for dementia. Dementia is a syndromic definition. It means someone has cognitive problems that prevent them from living life the way they once did. Alzheimer's disease is overwhelmingly the most common cause of dementia. 60 to 70% of people with dementia have Alzheimer's disease. There are other causes of dementia, including that some people can have a purely vascular cause of dementia, meaning that the blood vessels in the brain don't bring blood oxygen to the brain as well as they once did. The brain suffers injury from that, and that can result in cognitive problems. I believe diabetes is a very strong risk factor for cognitive impairment due to vascular problems. To my knowledge, no study has ever shown a link between diabetes and plaques and tangles, either at autopsy or with the new tools in the form of amyloid scans. Still, it's a debated topic. There are people who feel more strongly than I do in the opposite direction. The other thing I'll point out is that we've actually tested numerous diabetes drugs as potential therapies or risk-reducing agents for Alzheimer's disease, and none of them have shown a positive effect. Yeah?
At what stage would you accept someone into a clinical trial? Do you want them at early stage?
So the question is, at what stage would we accept someone into a clinical trial? Last year we published a paper called Recruiting People to Alzheimer's Disease Clinical Trials Across the Spectrum of Alzheimer's Disease. We're doing trials now in people who have perfectly normal memories. We're doing trials in people who have memory problems but don't yet meet the criteria for dementia. Of course, we're still doing trials in people who have Alzheimer's dementia, and less often, but we still like to do trials in people who even have moderate to severe dementia. A good clinical trial sets out to answer a question. It's very carefully designed so that we definitely answer a question. I teach, it's pretty much called Clinical Trials 101 at UCI, and the first thing I define for my students is the difference between a failed trial and a failed drug. In drug development, we will have failed drugs. It tells us not to study that drug anymore. We know we have a failed drug through successful clinical trials that answer a question. So one of the most important things when designing a clinical trial is who are you going to put in it? And that's called inclusion and exclusion criteria. So every clinical trial is going to have very specific criteria a person must meet in order for them to participate in the study. One of the strengths, we think, of our C2C registry is that people can tell us about themselves so that we can see if we can match people to the inclusion-exclusion criteria for a trial. Because for some of these trials in MCI now, 70% of the people who come to be in the trial don't actually qualify. And that just delays us. So we want to do things as fast as possible. It's imperative for us to do things as fast as possible. We need to answer questions, even if the answer is, this isn't it, let's move on to the next thing. Are there any trials? Not that I'm aware of. There are not any trials that look at 3 different treatments in one single patient to try to address plaques, tangles, and inflammation. And I don't know what it's going to take for us to get there. It's very complicated, especially if you factor in the role of the pharmaceutical companies. It's hard to get 2 different pharmaceutical companies to want to test investigational drugs together. That's a challenge. So many of us believe, and I think we will get there, but there are barriers to that people are working really hard to get past. There's also the fact that the amyloid plaques and the understanding of the amyloid plaques is at least 10 years ahead of our understanding of the tangles and the inflammatory response to this disease. And so there have been more candidate therapies against amyloid than against tau, which accumulates in the tangles, or in relation to the inflammation, which there are a number of different therapeutic pathways that we could attempt. So as these things catch up, I think we'll have more opportunity, and clearly that is a direction many of us want to go. I don't want to be accused of...
Being biased?
Yes?
I have one quick question. How long will it take for a drug that has potential to move through the FDA process? Is there anything being done to accelerate that process?
Yeah, so the question is, how long will it take for a drug to move through the FDA approval process, I'm going to add, contingent upon it showing efficacy in a phase 3 or really 2 phase 3 clinical trials. So the FDA has taken great steps to try to accelerate that. I don't think that's the problem that it once was. Some people are concerned that the pendulum may swing too far the other direction because they're talking about approving drugs with a lower standard for demonstrating efficacy than previously, with the expectation then that after approval, a company would do additional studies to achieve the old standards. So I don't think the FDA is going to be the barrier here. The barrier is getting the trials done.
Should you find a successful drug to eliminate, get rid of the capsid level, what damage have they already done to bread?
Yeah, so the question is, and I'll paraphrase it, but the question is, if we find a drug that's adequate to get the plaques and the tangles out, by the time they're already there, is there damage to the brain? And we're still very much trying to answer that question. Amyloid is clearly present for a long time before the onset of symptoms. Tangles are not. Tangles seem to be much more proximate chronologically to the onset of symptoms, and as symptoms go, so go tangles, or as tangles go, so go symptoms, more probably. That gives me hope because the linear phase of tangle deposition seems to be when the symptoms really begin. And it gives me hope that treatments that can slow or stop the progression of the disease, even once symptoms are beginning or even once someone is mild in their dementia, that we can arrest this disease or even try to reverse it, though that's, we're not there yet. It's possible that there will be damage done and we can't do that. We just don't know the answer yet. The single biggest thing needed to answer that question is an effective drug. That's the missing link, and obviously we're very focused on getting that.
Just a quick question going back to the blood-brain barrier. The recent research that's showing the deleted blood vessels in the brain, do you feel that this is a potential biomarker?
Yeah. I think that the work on the blood-brain barrier and leaky blood-brain barrier, so leaky blood-brain barrier is a problem in many diseases. And so whether it'll be a very sensitive or specific biomarker for Alzheimer's disease, in my mind, remains open, although I think very highly of the individual who's doing some of the main work on that topic right now. And I think it's really important, and I hope that we will be able to use it to develop specific biomarkers. I think it's important for a number of reasons, though. The blood-brain barrier, which is this very important protection the brain has to keep things that are in our bloodstream from the diet or from exposure to toxins. It's the job of it is to keep things out of the brain. It's actually what makes it really hard to develop drugs for the brain, because the brain is protected from letting drugs in. And so only certain size molecules with certain charge and other traits can actually get into the brain. But in disease, that barrier is less stringent, more permeable. And we're seeing things like the identification of DNA from viruses and other things in the brain of people with Alzheimer's disease, and it very much is possible that those things are happening because the blood-brain barrier is letting things in that it once didn't. And so I think it's important for a number of reasons. That's it.
Yeah. Shows promise, and then there were 2 others that showed promise.
Yeah.
You guys are studying those other 2.
Well, nobody's studying one of them right now.
So what do you need in order to be able to take those other 2 and bring them into your study?
Yeah.
And be a combination of all 3?
So the question is that we're studying aducanumab, which I said is one of 3 drugs that have been shown. It's not the only promising drugs, I should point out, but there are at least 3 that have been shown that if taken long enough can bring amyloid levels back to quote-unquote normal. One of them, we are in talks with the company that has another one. It's Biogen and Eisai together, but they're planning their next phase of studies. The other one is a drug called gantenerumab. It's being developed by Roche. We just didn't have the bandwidth to take on that study when they asked us to do it. These are money, space, and people. Yeah, but no, that's it. Yeah, we always want to do more. We're always trying to grow our team. We wish we could do every study with every company. We have our own studies that we're doing in clinical trials that are things that were identified or developed right at UCI Mind. So we have to be conscious of those things. But there's no company that has a drug in development that we don't want to work with. It's just a matter of timing in many cases. Right. I don't know. So the question is whether these studies will help people, and I'm going to say with chronic traumatic encephalopathy or CTE, which is a condition that is increasingly understood to come in professional athletes, especially football players, wrestlers, hockey players. So chronic traumatic encephalopathy is not Alzheimer's disease. Those individuals do not have plaques. They seem to have a form of tangles. And whether an anti-tau therapy could potentially be helpful both for Alzheimer's disease and CTE remains an open question. So hopefully, as well as other tauopathies, there are other causes of dementia where the tangles do happen in the absence of plaques. That includes frontotemporal lobar degeneration or FTD and progressive supranuclear palsy and some other things. So, you know, in our wildest dreams, we'd have an anti-tau therapy that helped for every condition in which abnormalities in tau accumulate in the brain. But until we have the candidates and can test them in all those populations, we won't know the answer.
You mentioned that the aducanumab decreased or helped to clear the amyloid from the brain.
Right.
You didn't mention any clinical correlation.
Yeah, so the question is about the clinical correlation between aducanumab and symptoms, the clinical presentation of the disease. And in fact, people who got the highest dose of aducanumab seem to progress the least over that 12-month study. And there was a striking dose response both in amyloid plaque reduction and in slowing of the disease. And that was never before seen. Very promising. It's still early. Small study. There are limitations to that study. Big studies are now happening. If the data look the same in the big studies as they looked in that small study, we've got something really great on our hands.
What was the age range back
Now you're testing my memory. So the age range, if I don't quote me, but I want to say it was 55 to 85 to be in that trial. You had to have symptoms of the disease and you had to have demonstration of amyloid plaques present in the brain. So that trial was not large. It was a very large phase 1B, but it was not an extraordinarily large study. It ended up being about 180 people total, including people who got placebo and all the different doses. So it's a small study.
Were there side effects?
Yes. So in every clinical trial, we are looking not only to see if a drug works, we want to know if the drug is safe. For all of the drugs that can bring the amyloid levels from elevated to not elevated, or from abnormal to normal, there is a consistent risk of side effects, which we are calling amyloid-related imaging abnormalities, or ARIAs. This means something about the process by which we are lowering the amyloid level, and some think we are pulling the amyloid out of the brain, and leaving the blood vessel walls across which we're pulling that amyloid a little bit leaky. And so it varies from drug to drug. It varies with dose. But somewhere in the ballpark of 20% in some of these trials of people will experience these abnormalities that we can see on an MRI. Most of the time, it has no symptoms associated with it, and it will go away on its own. And in some cases, we even give the drug again. Some of the times, it's associated with symptoms. Some of the times it's associated with bleeding in the brain. That's rare, but significant. And then it can definitely have symptoms, and then we definitely don't give the drug again. So the safety of these things will obviously be critical, but that's all part of drug development. An amyloid, sure. So I say amyloid. And I really am referring to a very specific protein amyloid beta. I could be even more specific, amyloid beta 42, which is a 42 amino acid amyloid. Amyloid is a term that can mean a variety of different proteins in a specific conformation, but the plaques in the brain are largely composed of beta amyloid of a 42 subunit composition, as well as a 40 unit composition. Charlie Glabe at UC Irvine studies amyloids, and he believes that, amyloid 38, amyloid 39, 41, and 43 are all pretty important too. But we know that in the plaques, it's mostly amyloid 42, and it's a sticky protein. And we all have a little bit of it, but people with Alzheimer's disease have these clumps together in the brain that clearly aren't supposed to be there and aren't in the brain of someone without Alzheimer's disease. It's all within the brain. I call it parenchyma. It's in between brain cells. Mm-hmm.
And when you showed the slides earlier about educational levels and lifestyle,
yeah.
I'm just wondering, what is your interpretation of the lower prevalence of Alzheimer's and dementia in that particular group?
Okay, so the question is about women in religious study. There are two, the religious orders study and the nuns study. Both are quite good. I am not under the impression that those women had lower prevalence of Alzheimer's disease, but it's been very interesting that we've learned a lot about lifestyle risk factors and risk for getting Alzheimer's disease and other forms of dementia. We learned a lot. Cognitive reserve, the idea that using your brain and maintaining an active cognitive lifestyle even into older life was largely born out of some of those studies. But it also showed that some of those things can date back. They looked at writing samples that women submitted to enter the nunnery, and they could see differences in the people who got Alzheimer's disease ultimately and the people who didn't in the sort of complexity of the language they used in their early 20s to do those things. Social activity is one of the things that was discovered in those studies. Nuns who had the same amount of plaques and tangles on their brain, but one was social and one was not. The social nun would perform better on cognitive tests throughout life, even in the presence of plaques and tangles. So a lot of interesting things, but I'm not aware of a study that said they are less likely to get Alzheimer's disease. Women are more likely to get Alzheimer's disease. This we know. It is mostly because you are so much better than us men at living to the ages when risk for Alzheimer's disease goes up exponentially. But that actually does not explain all of the difference in prevalence by sex. And with Maria Shriver, who has started something called the Women's Alzheimer's Movement, we have a new initiative at UCI Mind we're calling the Women's Alzheimer's Movement UCI Mind Women's Initiative to try to study the difference in biological sex or culture or gender and Alzheimer's disease. And the first study that was funded on this last year is about to report results looking at whether the genetics of sex, XX versus XY, impact microglia's role in the brain of a person with Alzheimer's disease. So very exciting stuff.
Are you seeing this rapid rise of Alzheimer's in other developed countries, like China, Japan?
Yeah. So the question is, do we see this rapid increase in Alzheimer's disease in other countries? And the answer is emphatically yes. Any place where people live into the 7th, 8th, and 9th decade of life is a place where Alzheimer's disease is a big problem. From a societal standpoint, China is really in a dangerous spot. I made the point at the beginning that Alzheimer's disease never affects just one person. The most common caregiver for a person with Alzheimer's disease in this country is actually an adult daughter. Most patients are women. Most women outlive their husbands. So the single most common caregiver is adult daughters, with adult daughters-in-law being a close second. You think about what's happening in China, aging population, massive population, one-child rule, more sons and daughters, they're in a world of hurt. But every place in the country, every place in the world where people live to older ages is a place where Alzheimer's disease is a big deal. We were the 12th nation to develop a national plan to address Alzheimer's disease.
How much exercise is exercise?
So, it's a great question. I ran here today. how much exercise is exercise or how much exercise is enough exercise is very much an open question, because what most good studies do is they test some sort of dose of exercise and they look at whether that's effective or not. And there aren't a lot of studies that look at a dose curve of exercise. And that's, if exercise truly turns out to be a recipe for prevention or delay, then we're going to have to do those studies. But right now, they're mostly focused on sort of proof of concept, more so than true dose response.
Is there a blood test now that can tell your probability?
Yeah. So the question is whether there is a blood test now, and I like the way you phrased it, for Alzheimer's disease to test probability. The answer is no, there is not a blood test now. There have been numerous reports over the years of promising findings in the blood or the plasma as potentially being predictive of Alzheimer's disease. To this point, none of them have panned out. But last year, there were 3 different reports of 3 different assays with slight variation in what they were looking at. But they all 3 seem pretty promising, so much so that I've got a grant going in next week that includes one of them. Because we think we may finally have something. It gets directly at a surrogate of what we think is happening in the brain, that is amyloid. The tests seem to be highly sensitive but not terribly specific. So that means that if someone's going to get Alzheimer's disease, they'll test positive on this blood test. But testing positive on the blood test doesn't necessarily mean you're going to get Alzheimer's disease. So someday, when we have preventative therapies, we may use a blood test to identify people who should go have a brain scan, to identify people who should go on a drug. And that's the kind of work that we're doing now, because that's where we need to go. Yeah?
Is there any testing for the specific gene?
Yeah. So the question is there specific testing for the APOE gene? The answer is yes. In fact, you can do direct-to-consumer genetic testing through a number of modalities, including 23andMe, and get your APOE results. The UCI Mind blog on our website has an entry about this very topic, and it's something I study. I remind you of Watson and Venter. I'm not a paternalist. I don't think we should prevent people from learning their genes. I don't think we should prevent people from being told their cognitive test results in our studies if it doesn't bias our data. That said, I know someone who participated in a cardiovascular study, and APOE is also a risk factor for cardiovascular disease as well as Alzheimer's disease. Her APOE status was revealed to her as part of the study unexpectedly. She carried 2 copies of the E4 allele, which put her at substantially increased risk for Alzheimer's disease. By her own report, she spent that evening on the internet with 2 bottles of wine, learning about what was being told to her. She was actually diagnosed with post-traumatic stress disorder. Again, by her own report, she nearly divorced as a product of the impact this disclosure had on her psyche. So I'm not a paternalist, but I do feel it's part of our mission to share these types of possibilities with people and make strong recommendations that if you want to learn your APOE genetic status or any other gene status, that you undergo education and genetic counseling prior to taking the test, prior to learning the results, and certainly after learning the results. And those direct-to-consumer services often have pathways by which you can do that, but they are not necessarily strongly encouraged, and they're certainly not covered in the cost of the testing kit. So we really strongly advocate for counseling before you even decide whether you want to do that. Once the toothpaste is out of the tube, you can't put it back in. Okay, Harriet's here, so I think that means I'm done. Thank you again. And while you're up here, I think we should give Harriet one more round of applause, and we'd like to give her a small gift. This is a commemorative plaque of the Alzheimer's stamp. So thank you for everything you have already done.
I'm going to ask you a question.
Oh.
Dr. Gill hasn't been able to eat, so let him eat, and then if there's more questions after, though some of you need to leave and some of you would want to stay and ask more questions. So go ahead and have your dinner or lunch. Okay.
Thank you.
And thank you very much. Okay, well, we know right now that we're living with the knowledge that there's a lot to be still done. And my family, and here I go, and the Brethren Community Foundation have participated with us, and we've been able to fund 2 research fellowships for 1 year each, which is very important, but they are 2-year fellowships. So anyone today that is interested in participating and meeting the challenge, I'm going to say, without you, and if not you, who? And if not now, when? And I know I didn't originate that, but we would very much appreciate any participation that you feel you can give to fund these, because without this research at UCI, we're in the dark. We're going to remain in the dark. And I thank you all very much for coming today. It's very important to me. Some of you are friends in so many different ways. I can't begin to thank you. But let's say if Dr. Gill wants to answer questions after, I hope he will. And any of you that have your dessert and need to leave, thank you. Leave a card if you have any interest in supporting us. Thank you.